Okay, this is question 2021, plane geometry part C. In part C, we're told a line is drawn from the point E and it's parallel to the line AC, and where it intersects the horizontal plane, we call that point P. So we're just going to locate that fairly quickly in elevation. So I'm going to go parallel to the line AC. From E. And it intersects the horizontal plane there. And that point is called point P. Now I also want to find that point P in the plan. So step one is I'm going to project point P down into the plan. So we know point P will be on this line and plan. Whereabouts exactly? Well, parallel lines are parallel in every view. So this is just another view. Same rules apply. If we go parallel to the line AC from E, it intersects here. So this is the point P. It's overlapping with my X1, Y1 auxiliary, but that's irrelevant. So I'm actually going to harden that line in because it's now part of the drawing. Here is the line E to P in elevation. And there is the line E to P. Sorry, I said that's E to P in plan. This is E to P in elevation. And now that it's part of my elevation, my X1, Y1 line doesn't extend far enough out for it. So I'm just going to extend my X1, Y1 line out to incorporate it. Okay, the second part of part C asks us to draw the projections of the line EP, which we've now done, and determine its inclination to the horizontal plane. All right, so very hard for me to determine the inclination of that plane to the horizontal, or of that line to the horizontal plane. What I could do is I could look perpendicular to the line and get an auxiliary, which would be an X3, Y3 line. And I could draw, this line would represent the horizontal plane. I would get a true length of the line EP, and that's one possible solution. But the quickest solution would be to just simply keep E as a fixed point and rabat P about until it's in a horizontal position. So that's the way I'm going to choose to do it. So if I just draw a horizontal line across from E. So this process is called rabatment, where you just spinning something about until it suits your line of sight. So I'm going to put my compass on the point E and take it to the point P and rotate P about until it is now in the horizontal position. And I'm going to call that point P1. And I'm putting that in as a dashed line because it's the same line, E to P, in a temporary position. There it is. Now the benefits of the line E to P1 is now I'm looking perpendicular to it. So whenever I draw the line E to P1, this is a true shape of that line, and the angle it makes the XY line is the true inclination of the line EP to the horizontal plane. So just going to take that up. P1 will be up directly above that, so it's going to be an elevation there. It doesn't change in height, it's just rotated outwards, so we just extend that P out. So in my elevation, this is the elevation of the point P1, and therefore this is the elevation or true length of the line E to P1. Okay, and the question asks me for the true inclination of the line to the horizontal plane. And there we have it. That's the true inclination of that line to the horizontal plane. So I've marked the dihedral angle with theta. I'm going to mark this as alpha. And then again, block capital text here, 4mm capitals. I'm going to say alpha equals true inclination to the HP. Okay. So there's the solution, and there's the annotation of it. So that's the end of part C. Moving now on to part D. Right, so for part D, we're told that AF has a true length of 70. Okay, we can't apply that in elevation yet. But because we know that F has a height of 10 mil, F is somewhere on this line. Because this is a horizontal line, therefore in plan A to F will be a true length. So, and we know that the true length of that from the question is 70 mil. So I'm going to take 70 millimeters on my compass now accurately. And I'm going to strike an arc from the point A that is 70 millimeters. Okay? And I know F will be somewhere on that arc because F is 70 millimeters from point A. This is a horizontal line, therefore A to F is a true length, so it will be actually 70 millimeters from point A in plan. Still no good to me. I can't randomly guess a point on that arc and bring it up and then draw the projections of it. So I need more information. So how I choose to do this is I choose to get an auxiliary view which contains a true length of the line AC. So I'm going to do that by projecting perpendicular to the line AC. Just think about our part A. Whenever I got a true length of the line AB, I projected perpendicular to the line, took a distances from 2 views back, that gave me the true length of it. So now I'm going to repeat the same process with the line AC. I'm going to project perpendicularly to that line. I'm going to project it out a wee bit further than usual. Out here, I'm going to take an X, what will this be? This will be my X3, Y3 line. So this is my X3, Y3 line. And I'm going to take my distances from 2 views back. So for the C line, I'm going to go back 1 view, 2 views. So I know C had a height of 55 mil. And A has a height of 10. So again, going back 1 view, 2 views, A has a height of 10 mil. So there's the point A, there's the point C, and that is a true length of the line AC. Now, what I like about this method is because I'm going to result in the true shape of the plane ACF. So I know from the question that A to F is 70 mil. So I'm taking 70 millimeters on my compass, putting it on my true shape part here now. I'm going to strike an arc from A that's 70 millimeters, and I'm hoping you can see that arc. You can see most of it. I'll just move this up slightly so you can see it. So that arc is 70 mil, A is the center point of it. Okay, I know then CF is 80 mil. So I'm going to take the distance 80 on my compass from C and strike an arc. And that, where the 80 millimeters from C and the 70 millimeters from A, those arcs meet, that is my point F. And because I started with a true shape of the, or true length of the line AC, I followed it up by adding in the true length of the line CF and AF. Now this is a true length of the line, or this is a true shape of the line. Okay, so now, again, I know that this point in this auxiliary view, I've taken my heights from 2 views back. So if I go for C, I go back 1, 2 views. So this height for C, this height for A. I know F has a height of 10, so I know F is going to be in this plane at a height of 10 mil. Not sure whereabouts on that line yet it's going to be, but I know F of this auxiliary view will have to be at a height 10 millimeters, somewhere on that line. So now I have a true shape of the line of the plane ACF. So now, because AC is a true length in relation to this exact auxiliary, I can rotate this plane ACF, primarily the point F, about the line AC. And if I rotate that around, simply it's going to look like a line that goes perpendicularly through the line AC. So if I set up my set square like so, and draw a perpendicular line from F through that. So if you can imagine, what I'm trying to do here is spin the plane about the line AC. So the line AC remains fixed, but the rest of the plane rotates around it. F would just look like it moves in this direction. So that would be the location of F in this auxiliary. So I'm just going to draw ACF in this auxiliary view. Okay, so that would be the exact location of F in this auxiliary from this direction. So now I'm just going to project F back into my plan, and that would be the exact location where it intersects that original arc that I drew from A. that's the position of F in my plan. And we already know it's at a 10mm height in my elevation. So that's the location of F. My elevation. Okay, and that is the full solution of that question.